Right, short video lesson on writing and understanding numbers in standard scientific form. Here's an ordinary number. There's an ordinary number, 7,500,000. And here is the same number written in standard form. The first part of the standard form number must be between 1 and 9.99, and then it's times by 10 to the power 6. And the power, in this case, is 6, but it could be any number. So we have a way of writing numbers that's particularly useful for very large and very small numbers, where it saves us writing lots and lots of zeros. So let's just go back a step. Here are the key numbers in our counting system: 1, 10, 100, 1,000, so on and so on. But we have a different way we can choose to write them if we want to. So 10 is 10 to the 1, 100 is 10 squared. 10 squared means you take 10 and you multiply it by itself. So 10 times 10 is 100, that is correct. It says here that 1,000 is 10 cubed. Well, what does 10 cubed mean? 10 cubed means take 10 and multiply it by itself by itself. 10 times 10 times 10. And 10 times 10 times 10 is 1,000, so that is correct. So we do have a kind of shorthand way of writing 10 or 100 or 1,000. We also have a shorthand way of writing 10,000. It's 10 to the power 4, because that means 10 times by itself 4 times, and that works out to be that. And in a similar way, we've also got those and those coming up: 10 to the power 5, 10 to the power 6. So one key landmark there is a million. A million is 10 to the power 6. We have an alternative way of saying a million. And then a billion is this one here. It's 10 to the power 9. And a trillion is 10 to the power 12. Right. So here's a sort of position value table, a bit like the one used in the video lesson about decimals. But what it's got here added this time is, as well as the normal column headings, the ones, the tens, the hundreds, the thousands, 10,000s, 100,000s and millions, it's also got those amounts written in this way using 10 to the power of something. So there's a million, 10 to the power 6. What this means is, there's a number there, so a 1 there, this is 1, it's one lot of 10 to the 1, one lot of 10 to the 1. This is 1/10. It's one lot of 10 to the minus 1 for a small number. 1 times 10 to the minus 1. This is 100. It's one lot of 10 to the power 2. One lot of 10 to the power 2. This is 100th. This is one lot of 10 to the power minus 2. Here we've got a much bigger number. We've got a number which is 1 and a bit millions. So 1 in the millions position. This digit here tells us the most about the size of the number. And it's the most significant figure in the number. What we've got is approximately 1 million. So in very approximately, it's 1 times 10 to the 6. But being a little bit more accurately, we'd say it's 1 and a bit millions. It's 1.2 millions. So 1.2 millions, 1.2 times 10 to the 6. Okay, don't change the power. It's 1 and a bit millions. You can be a bit more accurate if we wish to and say it's 1.23 millions. So that'd be 1.23 times 10 to the 6. Another number. This one here, we've got approximately, it's 4 and a bit thousands. So the key thing is it's 4 lots of 10 to the 3. 4 times 10 to the 3. We can be more accurate. It's a little bit more accurate, 4.2 thousands. 4.2 times 10 to the 3, or if you want, 4.23. So add more accuracy there if you wish to, but don't change the power of 10. Here now is a small number. The first figure, as we move left to right, is that 4 there. That's the one that tells us most about the size of the number. So this is 4 thousandths, and thousandths is the 10 to the minus 3 position. So we've got approximately 4 thousandths, so that's 4 lots of a thousandth. We can be more accurate if we want to. Again, 4.2 or 4.23, but don't change the power of the power of 10 at the end. Okay. Right. Working with numbers in standard form. What we have to move on to now is what happens. Okay, here we are. That number there, that's 7.5 million, so that would be 7.5 times 10 to the 6. This number here is 8 millionths. That would be 8 times 10 to the negative 6. Okay, so this when you're counting to find the position of the figures, don't count here. Don't use the one. Don't count from the ones position. Start counting here. So 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, 10 to the 5, 10 to the 6. That's the 10 to the 6 position. When we're going small, 10 to the -1 position, 10 to the -2, -3, -4, -5, -6, 10 to the -6 position there. Just be careful. Don't include that in your counting. It's 10 to the 1, 2, 3, 4, 5, 6. 10 to the -1, -2, -3, -4, -5, -6. Right. There are some numbers which you could write in standard form. Right. If you want to add or subtract numbers in standard form, you can only add or subtract things in maths that are alike. And we may need to use this idea here, that the idea that if you want to hold the value of something constant and you've got two factors of it, if one of these numbers gets larger, the other one has to get smaller to compensate. We'll use that idea in a minute. So if you want to add these two, 4 and a bit millions, add 3 and a bit millions, that's okay, easy, okay, because the numbers are already alike. All we do is add these two and we get 7.5 millions. 7.5 times 10 to the 6. There again, what will happen here is we'll get 12.5 times 10 to the 6. 12.5 times 10 to the 6. The trouble with that is it's not standard form, because it needs to be, the 12.5 number is bigger than it's allowed to be. It needs to be less than 10. So we have to use the seesaw idea. So 12.5 times 10 to the 6 would have to be rewritten as 1.25. So we make that the first number smaller, and the 10 to the power number has to be made bigger to compensate. So it wouldn't be 12.5 times 10 to the 6. It would be 1.25 times 10 to the power 7. With this number, we can't add them the way they are because they're not alike. The powers are different. This one, I would change this one, and I would make that into millions by making it 10 to the power 6. If we make that larger, this has to become smaller. This would become 0.4. 0.4 times 10 to the 6. Then you can add them. That's the idea behind adding and subtracting in standard form. It's quite tricky, quite tricky. On the other hand, multiplying numbers in standard form is actually comparatively easy. Multiplying doesn't care about order. We may have to use the power laws. So 100 times 10,000 is a million. So that two key power laws there, one there and one there, which you need to be aware of. So the shortcut is to add the two power numbers. Here the shortcut is to subtract the two power numbers. So if we want to multiply this number here by this number here, we're doing that times that multiplied by times by this. So we've got four things in a multiplication chain. Multiplying doesn't care about order, so put these two at the front of the chain. 3.8 times 4.3 times 10 to the 6 times 10 to the 5. 3.8 times 4.3 will be roughly 16. So you'll get 16 times 10, and then you'll add the powers and get 11, power of 11. So you'll have something like 16 times 10 to the 11. That's not standard form because the 16 number is too large. You'll need to use the seesaw type idea to change that into standard form. And just one division thing here. Treat it as being two divides. 8 divided by 4 and that divided by that. So 8 divided by 4 is 2. And here you have to use one of the power laws. You'll do a subtract with the powers. 6 subtract 6 is 0. So you'll have 2 times 10 to the power 0, which is 1. So your answer is just 2. It's how many? It's 8 million divided by 4 million, so it is 2. And that will do for now. Thank you.